the Coders Campus podcast, where you'll learn how to code from one of the best teachers in the industry. Whether you're an absolute beginner or a seasoned pro, the Coders Campus podcast will teach you what you need to know to master the art of programming. And now, your host, Trevor Page.
Ladies and gentlemen, fellow coders, welcome to this episode of the Coders Campus podcast. We've reached episode number 8 now. So as always, all show notes can be found via coderscampus.com/8. So today we are going to be migrating finally away from our previous episodes where we were talking about time leaf in the little 3-part series. So if you haven't heard that, make sure you check it out because time leaf is cool. Today we're going to be diving into the topics. Well, I'm going to be doing a little bit of a series on some of the more advanced topics, if you will, inside of the Java programming language. So again, if you are new to programming, if you're new to Java, I wouldn't recommend listening to these episodes just yet. I'd recommend checking out, I think via my other, my blog, which should still be up right now and running, howtoprogramwithjava.com/podcast. So let me just go there myself to make sure that link still works, howtoprogramwithjava.com/podcast. And you'll see there's a whole bunch of old episodes of the How to Program with Java podcast, which is what this podcast used to be called. Again, I'm sure you're tired of hearing that if you've heard plenty of the other episodes of the Coders Campus podcast. But in there, that's where I go over the whole topic of, Java and how to get started with it and how to do everything you need to do with the Java programming language. So that's more for the beginners. So check that one out. I just went there myself. It actually seems like it went to the wrong place, which is kind of weird. It looks like the link is more howtoprogramwithjava.com/Java-podcast, which is not a very friendly way to be able to say it. In any case, try that one. If the other one doesn't work, if /podcast doesn't work, then try /Java-podcast. Anyway, that's where you can go and learn more about the basics of Java. But today we're going to be diving into, and maybe in the next few weeks, we'll be diving into the more advanced topics of Java and maybe even Java 8 topics as well, like streams and all the cool things that come along with the Java 8 stuff. So anyway, that's probably what we're going to be looking at in the future. But for today, we're going to be looking at something called reflection. And I realized I hadn't done anything on reflection, Java reflection before, and that was just not good because Java reflection is something that, you don't use it very often at all. It's a very sort of a minimally used thing, if you will. But once you know that you can use reflection and understand how to use it, it becomes really useful for solving these random problems where it's like, oh, you know what? Java reflection would solve that problem. So anyway, without teasing it anymore, let me just dive right into what the heck Java reflection actually is. I'll start by saying if you've ever used JavaScript before, so if you've ever programmed with JavaScript for any length of time, you might be familiar with the eval function. And if you're not, that's okay. We'll talk about Java reflection and get into depths about what it is. But for those of you who may have some JavaScript experience, if you have used it and have used the eval function, that's exactly what Java reflection is doing here. Okay, it's a little bit different from how JavaScript uses it, but nevertheless, they're the very same concept. So, for the JavaScript coders out there, the eval function is used so that you can write any strings you like inside of the eval function, and then the JavaScript engine will interpret that string and run it like it was written as native JavaScript code. So this, execution of code written out as a string concept, like I said, is very similar to what reflection in Java will actually accomplish for you. So really, reflection in Java is a way to call the methods of objects without needing the actual reference to these objects. So another way to say it, the better way to say it is you can programmatically or dynamically, however you want to call it, you can programmatically or dynamically execute methods with reflection in Java. Okay? Dynamically execute methods with reflection. So how do we get started with this? How do we, talk about it? How do we learn about reflection and why it's useful and what we can do to use it? So one of the keys to working with reflection in Java is to make use of both the method class and the class, which is kind of funny. So the method class gives us access to some really cool stuff, namely the ability to invoke methods that you want to have, invoked programmatically, right? So you can have a method class that allows you to do a .invoke and invoke the actual method itself. So it's a very meta way of doing coding. Okay, it's a programmatic way of executing your methods. Let's assume that we're starting with a standard, plain old Java object, like a Java bean, or something like a Java class, like a user class, for example. I always use the user example in my past podcasts. I would use that all the time. So think of a user class, right? What does a user class have? Well, typically it has maybe an ID, an email, and a password or something like that. And then you'd have getters and setters. So you'd have your private long ID, you'd have your private string email, you'd have your private string password. So ID, email, password. And then you'd have your getters and setters for each of those instance variables, because that's what they are. You're creating instance variables with getters and setters, using all the appropriate good, methodologies for creating your your plain old Java objects, with data hiding and encapsulation, all that good stuff. Anyway, the user class, it's just that. It represents a user. So you've seen what it looks like to invoke any of the methods that are in the user class, right? So for example, if you wanted to invoke the getter method for a user's email, we would maybe get a user from a repository or something like that. So you do like if you're using your Spring Data stuff, you do user repository.find1, and you'd pass in a user ID, right? So that would load the user by ID, and you have the reference to that user object. And then with that user object, you would say, let's say a user would be the name of the variable. So you'd say a user dot get email, right? Nothing fancy going on there. You just load up the user and you say dot get email, right? We've seen this a million gazillion times. It's nothing crazy going on here, nothing fancy at all. So now how do we accomplish that same thing using Java reflection, right? That's the whole point here. How do we introduce Java reflection? So let's take that same code. So being able to load a user and then, invoke the getter method. Let's do that same code, only now we're going to invoke the getter method using reflection in Java. All right. So same thing happens here. We're able to, invoke the, user repository.find1 so we can get a user. That doesn't change. Although you could do that generically as well with reflection, but we won't, focus on that one just yet. We'll focus on the next part. So we have a user object. We'll call it a user, and that is, the user that's been loaded. Now, instead of saying a user dot get email, which is how we did it before, we want to do it in a slightly different manner. So in order to invoke this get email method in a generic and reflexive way, if you will, you need to use the method object. Okay, so you declare a method object, method variable. Okay, so you use the word method is the type, method with a capital M. That's your data type. Just like a string or an integer or a double, you're using a method is the data type. And you give it, that's the data type, so you need to give it a name for the variable. So you can, uncreatively call it method, if you will. So you can have method. So, that's just the, for lack of a better variable name, that's what I'll call it. But maybe you can call it the get email method. Maybe that would be a better, more descriptive name. Anyway, we'll call it method. So you declare the method and you assign it something, right? So in order to assign something to that new method variable, we need to give it an actual method. So how do you get a method from your object, the user object, more of the a user object? Okay, so you just type in a user dot, and you'd get all your normal stuff that you'd be able to do, like the get email, the get password, get ID, and the setters and all that stuff. But you also have some basic built-in stuff that comes with every single Java object. One method of which is called the get class method. So you can say a user dot get class. What that does is it returns the class that a user is defined as, right? Which is what? It is the user class. So that will return a user class, right? So a user.getClass, we get a user class. Now, from that, then you can also do another dot. Okay, you can assign that to a variable if you like. You can assign it to a class variable, but you don't have to. What I do is I do a user.getClass, and then immediately I do another dot. So then from there, we're invoking the methods that you can invoke on a class type of variable. So what methods can you invoke on a class variable? Well, one of which is the get method method. Okay, very meta. Get method. So you can invoke a user user.getClass.getMethod. And what does the get method take as a parameter? It takes a plain old string. So this is where the power of reflection in Java really comes from, because you can pass in any string and it will get that method based on that string, okay, if it can find one, right? Because you can also pass in some, garbage string, and if there's no method that matches that particular string that you're passing in, then it's going to throw an exception. It's going to throw a no such method exception. All right, but obviously we don't want to do that. We want to pass in a string that actually defines a method that we actually have, so the name of a method. So when you say a user.getClass.getMethod, you pass in the string get email. Now, I believe, and I'm almost 100% sure, you need to make sure it is case sensitive, right? It needs to be the right case. So it's going to be get in lowercase, and then email is going to have a capital E, because that's how the actual method is declared in your class, your user class. It's get email with a capital E. So you need to pass that in appropriately. So, very good. And again, that is assigned to your method variable. Okay, that get method will return a method type, right? And we've assigned that to a variable called method. Okay, great. So if we are able to, go through and Java is able to invoke that code and go over it and everything's good and fine and dandy, then that means that the method variable will have some values in it, right? The method variable is going to represent that method that you just told it to find on the user class. So it's going to represent the get email method of the previously instantiated a user object. Remember, because we got a user from the database. We did the user repository.find one, and we grabbed a user from the database. So this user is an actual user. It's like the Trevor Page user, if you will, or the John Doe or whatever. It's an actual user. So we're getting ready to invoke, but we haven't yet invoked the get email method for that particular specific user. Okay, so fair enough. So then how do we invoke that method? Well, you just say method.invoke, and you pass in the the object that you're using that in which you wish to invoke the method on. So in other words, you're passing in the a user object. So method.invoke, and you pass in a user because that's the class that you want to, or rather the object that you want to be invoking the method on. Okay. Why it doesn't know that already, I'm not exactly sure, because you had to do a user.get. Well, that's probably why. We did a user.getClass. So a user.getClass immediately goes to sort of the class level. It's the static, almost. It's not a static reference, but it's the class. It doesn't sort of look at the actual individual object. So hopefully I didn't lose you there with that. I was going on a tangent thinking, why do you have to pass in the actual object, the instantiated object, into the method.invoke method? But then I just realized why. Because let me backtrack and explain that. In our previous line of code where we said a user.getClass.getMethod, etc., you don't actually have to do a user.getClass. I believe you can just do user with a capital U. So you can actually just say user.class. And then you might be able to say user.class.getMethod. I'm not exactly 100% sure on that. I believe you can, because .getClass just returns a class. And if you say user.class, that just returns that class. So in other words, you can have a static way to get at the method on the class. So it's like a class level method. It's not tied to the individual instantiated object, the user, if you will, the individual users. Hopefully, again, I didn't lose you there, but that would make sense as to why you need to, in the second sort of line of code that we have here where we're invoking the method, doing method.invoke, that would be why you need to pass in an actual specific user. Okay, you don't pass in the whole class. You want to invoke a method on a specific instantiated variable, and we want to invoke the method that we just sort of found, which was the get email method. So that, I believe, I'll stick my guns on that one. That is the reasoning behind it. That makes 100% sense in my mind. So, hey, it must be true, right? So yeah, method.invoke, a user is what you pass into that method. And what that will do is it will invoke that method, and it will know, at least it should know, that it wants to return a string. Although that might not be true, you might need to cast it to a string, unless you're able to use Java, the generics, to be able to specify that this method is of type. Well, that wouldn't work. No, you wouldn't be able to do that. So I believe you would need to cast it. probably method.invoke would return a generic object. So you would then need to cast it to whatever, type it is that it should be, which in this case is a string. So you cast it to a string, and then there you go. You have invoked the get email method for the specific user that you loaded, and you've casted it to a string, and now you can do whatever you want with it because you've just invoked it. So it will return whatever the get email method will return, right? That's the sort of generic way, the reflexive way of going about executing a method, like I said, dynamically, programmatically, however you want to look at it. All right, so now also what I just did, I paused the recording just to test out what I had said before, just to make sure that I was giving you correct information because, hey, that's the kind of guy I am. I don't want to feed you false info. And it is true. What I said was true before with respect to, you can say user.class.get method, or you can say a user.getClass.get method. Both will be able to do the exact same thing. But what you need to understand about what I said there is that it's doing it in sort of the class level way. It's the almost like the static way of doing it. There's no real reference. The method has no reference to the individually instantiated user, no matter which way you do it. Okay, so that is why you need to pass in the actual, when you do the method.invoke, you need to pass in the actual instantiated user itself, because it otherwise wouldn't know what user to invoke that get email on, right? Because you're doing get email on a particular user, and what if you don't know what user you need to invoke that method on, right? You'd have to invoke it on, you can't, it's not a class level method, it's not a static method, so you can't just invoke it without a reference to the object. All right, cool. Now, another thing that you need to, realize is that there are some exceptions that you'll need to catch or handle or throw if you don't want to, deal with them. There's no such method exceptions. Like I said, if you pass in, when you use the .get method way of getting methods, and by way of passing in the name of the actual method itself, there's a potential for there to not be a match, right? If you pass in an incorrect method name, if that method doesn't exist, then it's going to have to throw a no such method exception, and you'll need to do whatever it is that you want to do in the case that, that particular error happens. There's also a security exception that you should be caught or thrown, whatever it is handled, I guess. I think this one happens if you're running, the JVM or something with a particular, user or whatever in whatever system you're using, whatever OS operating system you're using, that might not have access to be able to invoke methods in this dynamic fashion using reflection. I believe there's a way to disable that so that you can say that people can't write code that will, reflexively invoke methods. So you can actually turn that on, and therefore the security exception would be thrown. Otherwise, by default, for the most part, I don't think anyone probably listening to this podcast will have to worry about that. That's more of an advanced feature, I believe. But who knows? I've never had to deal with that, so I don't know all the details around it, nor have I ever had to deal with that before. So that's why I don't think it's truly that important for you, but hey, you never know. You can always go off on your own and learn about it if you like. That is what the Google is for. There's also a few other exceptions that can be thrown, like an illegal access exception, illegal argument exception. So these are things like I haven't gotten into passing in arguments to the methods. So if you don't pass in the correct arguments or the correct types or whatever, you'll probably get an illegal argument exception and all that sort of thing. Those are the most common ones that you'll get, is either the no such method exception or the illegal argument exception. Okay, they're pains in the butts when you have to deal with them, but hey, that's just the way it goes. All right, cool. So I guess that's a good sort of segue, if you will, into how to invoke methods with parameters using reflection. So, like I said, we've sort of talked about how we can invoke a method that takes no parameters, like a getter method. So let's have a look at or talk about how to invoke a method that takes an argument, like, for example, a setter method. Okay. And now, just in case you're thinking that reflection is only for getters and setter methods, that's not true at all. That's not the case. You can use reflection to evoke almost, any methods you like. And I say almost any methods because I'm not exactly sure if it can be used to invoke absolutely every single type of methods you want. Perhaps there are some types of methods that you can't invoke with reflection. I can't think of anything off the top of my head, but hey, I'm just covering my own butt here. Who knows? Take that with a grain of salt, if you will, because, I believe it can execute every single method, but, who knows? All right, so having said that, let's talk about how we can invoke the set email method with Java Reflection. So the same thing happens. You'll instantiate your user by getting a user via the user repository. So we'll do a user repository.find1. Boom, I pass in a long, maybe 1 as the long variable for the ID, or 2 or 5 or 10 or 15 or whatever you want to get a user. So long as that user exists in your database, it'll be loaded up. And then what you can do is you can say, when you're creating your method, so this is the same steps, this is the exact same steps as before, it's just there's a little bit more work that we need to do. So you can say a user.getClass.getMethod, and then you pass in the name of the method. In this case, it's set email. Set is lowercase, email has a capital E. And then we have to put a comma. So there's another argument we need to pass into the getMethod method. And the argument we need to pass in is the data type of the argument or the parameter that the set email method will be taking, right? So essentially what we're telling it is, we're telling it what the method signature is. If you're familiar with what a method signature is, a method signature is made up of the method name and the arguments that the method takes. That's what a method signature is. In Java, if you can have methods that are named the exact same name, but take different arguments, and that's perfectly fine. There's no compilation error. It's as soon as you have two methods that have the same name and the same method signature in terms of what arguments they take. If they take the same, if you have a set email that takes a string, and you have a set email that takes, an object, then that's fine. But if you have another one that takes a set email method that takes another string, then that's incorrect. Those are identical method signatures, and you'll get a compilation error because there's a duplicate. So this is just a way to uniquely identify methods. Pass in the name of the method as well as the arguments that it takes. So for our example, we'll do, a user.getClass, or you can do user.class.getMethod. In quotes, we'll pass in set email, comma, and the string.class, because it takes a string. So you need to pass in the class, the data type that that the method is taking. So in this case, the set email takes a string, and that's the email that we're passing in. So that is a string.class that we'll be passing into the get method. Very good. So now when we invoke the method, so we do method.invoke, we once again need to pass in the fully instantiated object that we wish to use to invoke this method on, or on which we would like to invoke this method. I guess that's the grammatically correct way of saying it. We pass in the a user variable, and then we do a comma, and we have to pass in the actual data that we would want to pass in if we were invoking the setter method. So if we were saying, a user.setEmail, we would pass in an email as a string, right? So when we do method.invoke a user, we also need to pass in the string. So you do comma and you pass in, an email address like trevor@craftycoder.com. And there you go. So you still all the same, no such method exception, error handling that you have to do, security exception, illegal argument exception, all the other exceptions that you need to do and catch and deal with, you'll need to handle. But there you go. The only difference between those two pieces of code that I just talked about is that we have to pass in an additional parameter in both the get method and the method.invoke method. Okay. That parameter being a representative of the actual parameters that the method takes. And if there was more than one parameter that this particular method took or could take, then you just have to keep on putting commas and passing in the appropriate things like, string.class, comma, maybe integer.class, comma, double.class, whatever parameters that method takes, you'll need to appropriately put them in. And when you invoke it, you also need to pass in the appropriate data. All right, cool. Now, the one last thing, how long are we doing, or how good are we doing on time? Not bad. We're on less than half an hour still. So last thing that is sort of important to talk about, every time that we've been talking about this stuff, we've been doing the get method way of, getting a method, where we pass in the name of a method. But what happens if you don't know the name of the method that you want to invoke? Or maybe you have an idea of the name, or maybe you want to invoke many methods in a class. Okay, maybe you want to invoke all the setter methods or all the getter methods or something. Who knows what the scenario would be. I can't think of a good, maybe a good real world scenario is, for example, when you need to save values via an Ajax call. This is kind of a pretty advanced topic. Let's say that we have a form, an HTML form that needs to be filled out on a web page. and the values will be sent to a database for storage. Okay, pretty much as soon as the form fields are filled out. Okay, so for example, we have, let's say we're creating a user, and for some reason, as soon as you type in the username, it'll go and immediately try to save that username into the database. Okay, as soon as you tab out of the field. And then as soon as you type in a password and tab out, it tries to save the password. Okay, that's not a great real world example because that wouldn't be a good, you wouldn't probably want to do that in the real world, but there are real world examples where that is the case. Like for example, when you are, a lot of new web pages these days, new web apps, if you will, they don't have a save button anywhere. Because as soon as you type stuff in, it automatically saves it to the database. So that's a better example of what I'm talking about here, right? So basically, what usually happens is with those types of things where you're typing in and you tab out and immediately it saves the field, that usually happens via an Ajax call. So that's a scenario that we're dealing with here. But in order to make that code work, reflection plays a very important role, okay? Because you need to have a very generic way of being able to save the fields that you're typing in on the form fields. You need to have a very generic way of doing that, and reflection is a great way to solve that problem. So I have a great snippet of code, actually. I'll paste it into the show notes page. So if you go to coderscampus.com/8, I'll show you a great snippet of code with plenty of comments all over the place that explain exactly how I use this code. But what I'll do is, instead of going through all the code, because I think it's like 36 lines of code, I don't want to go through every single line with you. What I will go through with you right now is the general idea of how to, essentially go through all the methods of a class. All right? You might already have a general idea of how you might want to do this too. So let's say we have a user, the user class, right? So you say user.class, and then instead of saying user.class.getMethod and passing in a method name, you can say user.class.getMethods with an S. Okay, and that takes no parameters. What that will do is it will get every single method inside of the user class, and it will assign it to a method array. So it's an array of method objects. Okay, which represents each, one of the each one of the nodes, each one of the indices inside of the method array represent one of the methods inside of the user class. So if we go back to our user class, that's the get ID, set ID, get email, set email, get password, set password. Okay, so there's 6 methods. So we'll have 6 methods assigned to a method array. Okay, call it whatever you like. We can call it methods, for the lack of a better term. So now we have this variable called methods, okay, and it has 6 methods inside of it. So now we can treat it, since it's plain old array, we can treat it like a plain old array. We can iterate through it. So we can maybe do a for each loop on it. We can do for method, a method in methods. So method space, a method space, colon, space, methods. So I just say method, a method in methods is sort of how I say it out loud, but that's not how you type it in Java code. You use a colon, not the word in. In any case, that's the for each loop, right? You're doing a for each loop through all the methods in the methods variable, which is all the methods inside of the user class. And then you can go through each of the methods and treat them like you would any other method. So you can say a method dot get name to get the name of it, to check and see what the name of it is. You can do a method dot invoke, right? That's how you invoke each of the methods, and so on and so forth, right? There's a few things that you can do with the method variable, but just the same as we were doing above. The only difference is we didn't do get method and pass in the method name. We just got all the methods. Okay, so the only repercussion here, the only difference between, I shouldn't say repercussion, the only difference between our previous code and this one using the get methods with a pluralized version of the method called get methods, the only difference is we don't have to handle the no such method exception anymore. Okay, previously we were passing in the name of a method, which could potentially be an invalid name of a method, but when we do get methods, it's actually getting each and every one of the methods that do exist inside of the user class. So there's no way that Java will accidentally get the wrong method name or something like that. So you don't have to handle that exception. You don't have to handle no such method exception. But I think all the other exceptions are still up for grabs, because when you invoke the method, you can still pass in an invalid parameter type or what have you, and so on and so forth. So those things you still need to handle. In any case, I've got some great generic code. It will be very cool, very eye-opening for you to go through and take a look at it. Like I said, I use this myself when I'm doing, like I said, the Ajax call from the front end. So you have a form, and you want to dynamically save the form fields as soon as they tab out every single time using Ajax. So the way I do it is with some cool generic reflection code. So that's the code that I pasted in, and you can have a look at it and be in awe of how cool it is. If you are a nerd like me, I find that code to be very cool. So awesome. I think that's about it. There you go. 30 minutes. I try to keep these to about 30 minutes so I don't bore your head off. So great. Thanks so much for listening to this episode. Like I said, in future episodes, I'm going to be diving into more topics, more advanced topics, hopefully on the Java language, perhaps along the terms of, or along the lines of Java 8 stuff. So yeah, there you go. And if you haven't, I'll say this once again, if you haven't left a rating and review for the show, I still have the contest going on until just about the end of August. As of the date of the recording of this episode, I'm recording it one day before it goes live. So I'm recording on August 4th, 2016. So for those of you who are in present day, who are listening to this on August 5th, 2016, you still have a good 4 weeks to go before, 4 weeks? Hold on, 3 weeks to go before, I announce a winner for this contest, where you can, leave a rating review, take a screenshot of your rating review that you leave via iTunes. That's, the main thing that I'm asking you guys to leave a rating review on. You can go to coderscampus.com/iTunes, or you can just go to iTunes, download it yourself, and search for Coders Campus Podcast. I think I tried searching for Coders Campus, and it didn't work. I don't know if that's fixed or not. Maybe I can try that now. But I think as soon as I type in Coders Campus Podcast, then I found it. And then you can go and click on the, reviews tab, and you can leave a rating or review. In any case, take a screenshot of that for me when you leave a rating review, and then email it to me so that I know who it was that left the rating review, because otherwise I have no way to contact you if you don't email me. I won't have your email address if you just leave the rating review and do nothing else. So please do leave a rating review on iTunes. You can search for Coders. Let me do Coders Campus right now. Campus. In front of your very ears. Oh no, it does find Coders Campus Podcast. So anyway, you can type in Coders Campus or Coders Campus Podcast. Click on Coders Campus Podcast, and you'll see there's a ratings and review tab. You click write a review, and then you'll be able to write a title for the review, give it a rating, and give an actual text review. Take a screenshot of that bad boy, email it to me at trevor@craftycoder.com. Again, Crafty Coder has no E in it, so if you type an E in Crafty Coder, you're doing it wrong. Trevor@craftycoder.com. Email it to me, the screenshot, and you'll be entered in to win one of 3 prizes. The grand prize is a $100 gift card to Amazon, plus a 2-month subscription to the Coders Campus membership platform website. And second and third prizes are the Coders Campus memberships, 2-month Coders Campus memberships. I mean, valued at, right now I'm charging, it's about $97 a month. So really each of those are valued at, almost $200. And the grand prize is essentially $300. So there you go. Please do leave a rating review. That's what helps me get the word out about this podcast, gets more people downloading it, and gets me, creating these free episodes for you on a regular basis. So if you enjoy, learning about Java for free, and I'm going to be teaching you about many other programming languages in the future, because this is the Coders Campus podcast, not the Java podcast. I've got plenty more to talk about, so I'd love to keep on teaching you this stuff for free. So the more reviews you can leave me, the more free stuff I can give back to you in return as a thank you, and we all live our lives happily ever after. Cool? Cool. So I won't bother you about that anymore. Thank you so much for listening to the episode. Again, coderscampus.com/8 to get the show notes for this episode. And don't forget to leave a rating review. Can't wait to see you in the next episode. Take care of yourself. Thank you so much for listening. Bye for now.
Thanks for listening to this episode of the Coders Campus podcast. But before you go, Trevor has a favor to ask you. In order to keep these episodes free, he'd love for you to leave a rating and review the podcast on iTunes. Just go to coderscampus.com/review to leave your own rating and review of the show. So if you have 30 seconds to spare right now, please help out by leaving a rating and review via coderscampus.com/review. It will ensure that you continue to get these awesome free podcast episodes each and every week. So if you like free swag, head on over to coderscampus.com/review. Happy learning!